Welcome to Science Uncovered. This episode is all about fracking. Hydraulic fracturing, otherwise known as fracking, has been widely reported in the news lately. There have been two main sides to the debate. One side saying that it would be the saviour for all of our energy and economic problems, and with the other side saying it will cause irreversible environmental damage. I'm here today to try to explain the scientific facts behind fracking and the potential problems and alternatives to the process. We are filming here today at the Ardingly Reservoir, which is the source of the River Ouse. The reservoir is home to a varied ecosystem including kingfishers, eels and carp. The reservoir also provides water for 168,000 people living in Lewis and the surrounding areas. Quadrilla, a UK-based oil and gas exploration and production company, performed experimental drilling nearby in Balcombe, which ceased as of September 23rd, 2013. We are students from the University of Sussex. What is fracking?
Fracking is like trying to get gas out of the ground, and they use a lot of chemicals in the process, and it can be like quite destructive, but I don't know the ins and outs of it necessarily, just a way of getting gas out of the ground, I suppose.
I don't have a clue.
Something to do with friction. That's an answer that someone would want.
I thought that fracking was when you put water like really fast under the ground and then it made oil come out.
It has something to do with chemicals in the ground. Fracking is when they pump water and various other liquids into the ground to break hard rock and so on to release gases and petroleum within.
As far as I know, it's the pollution of water supply. It's been quite controversial because it has some places caused like earth tremors and has in some cases actually released into the water supply. Chemicals
getting into the water table and thus it can lead to poisons and so on, getting into people's waters. And I think even earthquakes are attributed to it. Yes?
Well, the process of fracking is to release gas which is tightly locked into shales deep below the surface. Shale rocks are highly over-consolidated, having been formed 160 or more million years ago, where the water has been removed. And of course the carbon that was deposited with those minerals have been locked very tightly within the shale. So the process of fracking is to introduce water, sand and some chemical agents to assist the process to reopen some of those micro cracks and allow the gas to then flow back into the well.
Hydraulic fracturing is the process of drilling a well vertically into the ground and slowly making this well horizontal as it reaches the shale rock. After this, the well is cased using cement. Once this process has been completed, explosive charges triggered by electrical current are used to perforate holes along the shale formation to allow the gas to flow. After this, a mixture of water, sand and chemicals are pumped under high pressure underground to open up fractures as well as to create new ones. This is done to release the methane that is stored in the shale rock 5,000 to 9,000 feet below the ground. According to the most recent estimations from the Royal Geographical Survey, there is said to be 20 trillion cubic feet of recoverable shale gas in the UK alone. However, fracking requires up to 4 million gallons of water over the well's lifetime. Sand is also required to hold open the micro cracks formed below. Chemicals are also used, and we'll discuss those later on.
Obviously the mix of water and sand opens micro cracks. The sand enters those micro cracks to keep them open, but the sorts of fractures that we're talking about, you would probably need a microscope to actually see. So again, one hopes there aren't misconceptions that these great fissures are being opened up deep in the earth. Is clearly not what's happening.
On the 1st of October 2013, the University of Sussex held a debate on fracking with speakers for and against the motion, is fracking a blessing or a curse?
A problem that has environmental issues, democratic issues, it has health concern issues, it is the end of cheap fuels, it is a diversion from what we should really be doing, which is renewables and energy efficiency.
One of the main problems people have with fracking is the chemicals used in the process.
Already it's encouraging to see some of the UK companies reveal the chemicals they'll be using. Some companies in the United States use in excess of 750 different chemicals. Quadrilla plan to use just 4.
Quadrilla has now released the 4 chemicals it plans to use in the fracking process. These include glutaraldehyde biocide. This will be used to cleanse the water and remove bacteria. Polyacrylamide. This will act as a friction reducer to lower the amount of water required to frack. Sodium salt. This will allow tracing of the fracturing fluid to check its progress down the well. And hydrochloric acid. This helps dissolve minerals and form cracks in the rock.
Any type of contamination of the river system, the catchment area of the River Ouse and the River Ada nearby, would be disastrous from an ecological point of view. Any type of contamination, and I understand that fracking involves the pumping under high pressure of water with a number of chemicals, including hydrochloric acid, into the cracks of the rock and releasing CO2 and methane and all sorts of other natural greenhouse gases that could affect the environment as a whole. But if those chemicals were to get into the catchment of the Ouse, you would see a massive disruption of the ecology.
25% to 75% of the water that is pumped into the ground eventually returns and is classed as produced water. The fluid is mixed with sand, methane, chemicals used in the process, and minerals from the shale rock. In the UK, the water would have to be stored in containers, but there is potential of waste water spillage. There are processes such as membrane filtering that will allow the oil and gas companies to reuse the water in other fracking sites. The water that enters the well is a mixture of fresh water from local reservoirs such as Ardingly and water from other fracking sites.
One of the things that we're really concerned about in Lewis is we get most of our drinking water from around the Balcombe area. So if they start putting chemicals into the aquifer, into our drinking water, we're going to have huge problems.
There has already been 2 earthquakes caused by fracking in Britain, both in Presaw in Lancashire. They measured 2.3 and 1.5 on the Richter scale. However, these earthquakes were tiny and left no structural damage. Even so, Quadrilla suspended fracking at this site.
One well out of 200 that has created an earthquake. And if you look at the statistics, what that says to you is that there's less than 0.5% chance of any well generating an earthquake, based on 40, 50 years of fracking history here in the UK. My own view is that it is very unlikely that that frequency will increase. If anything, it could go down with more exploration wells being drilled. So it is an extremely rare occurrence. And thinking a bit about the geology in the United Kingdom, we are in an aseismic area. We don't suffer problems of major earthquakes, from natural processes, and therefore, the setting is such that we wouldn't anticipate earthquakes being triggered by this process.
The main issue the campaigners on the anti-fracking side face is the problem of climate change. The Intergovernmental Panel on Climate Change, the IPCC, have said that scientists are 95% sure that humans have been the dominant cause of climate change since the 1950s. The process of fracking means that carbon stored in the ground will be released into the atmosphere as carbon dioxide, thus contributing to climate change. The other problem with the process of fracking is the suspected methane leakage from wells.
When you burn gas, you produce CO2 and you produce some water. It's better in carbon terms than burning oil or burning coal. But what seems to be happening at fracking sites is that methane is being released to the surface. It's not all being captured. Now, methane in the atmosphere is 40 times worse than CO2. So if you burn methane and you release it into the atmosphere at fracking sites, actually you're not benefiting the atmosphere. You're not improving our chances of stopping runaway climate change. You're contributing to it.
I asked all the experts I interviewed, what does the future hold for fracking?
a full environmental risk assessment needs to be done, and an impact assessment, which includes assessing possible damage to ecosystems and ecology.
My view is that certainly gas is a cleaner form of energy than coal. So I personally rather see more gas-fired stations than coal-fired stations. And again, that is part of the programme here. And that will actually, in turn, reduce the amount of carbon emissions that we are presently making.
It seems to me that we're really wasting our time with fracking. It's going to provide very little energy. It's not going to reduce household bills. It's fossil fuels which shouldn't be burned. They need to be left in the ground. If we burn them, we're going to continue that step towards runaway climate change. We need to concentrate on renewables. There's plenty of potential in the UK. Look what some countries in Europe are doing on renewables. It's astounding. We're not going so fast. We could do.
Although hydraulic fracturing in the UK is only in its infancy, there is urgent need for economic and scientific research to allow the public and the government to form an overall judgment over whether fracking can satisfy Britain's ever-growing energy addiction. Thanks for watching today's episode of Science Uncovered. Please like us on Facebook, follow us on Twitter, or click on the video to watch more Science Uncovered.
Ridiculous!